Unit 5, Curve Sketching and Extreme Values, Subsection 1, Graphical Features. So in this unit, we're going to be doing a lot of things. It's highly graphical because, of course, we're sketching graphs. Okay, finding zeros, max min points, the whole work. So the first little bit, so let's go through the curriculum bullets or the I can statements. I can determine where a function is increasing and decreasing by analyzing the derivative of the function. Okay, you're going to be able to identify local max and mins and absolute max and mins by analyzing the graph. You're going to learn something called critical numbers of a function and how to find them. Okay, how to find potential maximum minimums using the first derivative. And you're going to be able to identify which potential maximums and minimums are actually maximums or minimums using the second derivative test. Okay, so part 1, increasing and decreasing functions. So we have already discussed increasing and decreasing functions before. We first talked about that when I made you sketch the derivative given the graph of the original function. Back then, though, we only discussed increasing and decreasing functions in a very, very general way. Okay, so now our discussion is going to be a lot more focused and a lot more mathematical. So, to begin, I want you guys to sketch this parabola. So y equals x minus 3 squared minus 4. Okay, and this is vertex form or standard form of a parabola. And remember, you change the sign on the x part, so that's positive 3, and then leave the negative 4 alone. So this vertex is positive 3 and negative, well, that's terrible. Okay, positive 3 and negative 4. Okay, and it is just your everyday standard parabola. So, okay, so something like this. Good enough for what I need from you guys. So, awesome. Now, what is happening to the value of the function? So, what's happening to the y value as x moves from infinity to 3? So, infinity is like way over here somewhere, all the way to 3. And if you have a look at that, okay, so the y values are, you start off really, really big at infinity, and then as you approach 3, they're getting smaller and smaller and smaller. Okay, and then finally get to negative 4. Okay, so what we can say is the y values are decreasing. Okay, what's happening to the value of the function, or so the y values again, as we move from positive 3 to infinity? Well, the y values, that time they're getting bigger, so they're increasing. Increasing, yay. All right, so now let's find the first derivative of this particular function. So y prime. Okay, so let's see. The 2 is going to pop down. So 2x minus 3 to the 1. And then, of course, the derivative of negative 4. Oh, I've got to chain rule the inside part. Well, chain rule of that is just 1. So that's not a big deal. Okay, and then the derivative of the negative 4 is just 0, so we don't have to worry about it. So really, if we distribute that in, the derivative is 2x minus 6. Okay, and I want you guys now to just think a little bit about what does the first derivative mean for a graph. And I just want you to recall that the first derivative is the equation of the slopes of the tangent lines. Of the slope of the tangent line. Okay, and I guess technically it's lines because you could have lots of tangent lines depending on where x is, but when you substitute a value for x, we're going to get the equation of the tangent line. Awesome. All right, so now I want you guys to redraw that graph. So it was at 1, 2, 3, and negative 4, so about there, kind of looked like this. Okay. All right, so I want, okay, well, I guess we're going to go up to 0 here. Okay, so sketch the tangent line to the curve at 0, at 3, and at 5. So at 0, we're kind of up here. So the tangent line is really, really steep. Maybe I should draw that in red so you guys can see it better. Okay, good enough. So really, really steep. Okay, at x is 3, that's this guy. Well, oh, wait a sec, that's the minimum, so the tangent line here is 0, and at x is 5, so 3, 4, 5. So that's that point. So it's kind of there-ish. Okay, so I guess what I need you to notice is that the slopes of the tangent line for a decreasing function, look, the slope of that tangent line is negative, the slope of that tangent line is 0, and the slope of this tangent line is positive. Alright, so let's see, what's the value of f prime of x? So remember, and I'll write it again, so f prime or y prime, they're the same thing. Remember we said that was 2x minus 6. It's on the last page. 2x minus 6, so at 0, so y prime at 0 is negative 6. Y prime at 3 is 0, right? 2 times 3, okay, 6. 6 minus 6 is 0. And y prime at 5, well, 2 times 5 is 10, minus 6 is 4, so positive 4. Okay, so I want you to, or let's write down the summary stuff. Okay, so f of x, so when x is 0, y is 5. Okay, when x is negative 3, when x is 3, y is negative 4. And when x is positive 5, y is 0. Okay, the first derivative of these things, so at 0 we said it was negative 6. This was 0, and this guy was positive 4. And remember, when we said it was increasing or decreasing, right, from negative or infinity all the way up to 3, we were decreasing. Okay, this guy is neither or 0. Okay, and when it was positive 4, we were increasing. Sorry, my pen doesn't write in really small places a lot, but yours is better. Increasing, is that's what that's supposed to say. All right, anyways. Okay, so from the above chart, the important concept is that the function is decreasing or getting smaller. Remember, the y values are getting smaller when the first derivative is negative. Okay, the function is increasing when the first derivative is positive. Okay, so positive tangent lines means the function's getting bigger. Okay, and then transition occurs, or between them occurs when the first derivative equals 0. Okay, awesome. Now, there's several important parts for us to be aware of as we're moving forward. Being able to find the zeros, make a quick, really rough sketch of a function is really important. Okay, we talked about these skills in Unit 1, and if you're not very good at that part, maybe you should review them. Anyways, try and follow the next few examples, and if you can follow them nicely, there's no need to review. If you're struggling with where I'm getting stuff from, maybe you should go back to Unit 1 and just kind of touch up a little bit. Okay, but don't do that now. Let's see how it goes. All right, here we go. Number 3, or page 3. Examples. Number 1, find the intervals on which the function that is increasing and decreasing. So I'm going to teach you guys a couple of skills while we're doing this stuff. It's not crazy hard. It's not crazy new. Okay. Anyway, so all we're going to do is we are going to find the first derivative, because that's kind of the important part. So, first derivative. Okay, so f prime of x equals. Alright, so the derivative of 1 is 0, derivative of negative 5x is just negative 5, and the derivative of 4x squared is plus 8x. Okay, so no big deal. Okay, remember, we want to know the transition between increasing and decreasing is when that first derivative is 0. Hey, we've done this before. Set that derivative equal to 0. That's how we find the maximum minimum points. That was the point of all of last unit. Okay, so let's move the 5 over. So 5 equals 8x. So 8, or x equals 5 over 8. Okay, so once we get where our first derivative is equal to 0, what we're going to do, everyone, is we're just going to make a little number line here. And we're going to put, these are called critical values. Okay, well, that's coming up here in a little bit, so I'm spoiling the future. But anyways, so these values here, when the first derivative is equal to 0, okay, so that's going to be kind of an important point. So that's 5/8. And what it does is that splits the number line in two distinct regions. So basically what that means for this graph, there is going to be two regions, a region of increase, a region of decrease. Now it is possible to have two regions of increase and two regions of decrease. We'll get to that here later. But for right now, there's only one critical value, okay, and it splits this number line into different regions. So what we're going to do is we are going to test numbers on each side of the region, each side of the critical value, to see what's there. Now, if it's possible, 0 is always a really good pick because 0 for x is just the constant term, right? Okay, and try and pick nice numbers like whole numbers, 1, 2. Every now and then I'm going to force you, like when there's two critical numbers that'll say 1 and 2, you'll have to put like 0.5 in between them. But one thing at a time. All right, so 5/8 is in between 0 and 1. Okay, so those are some small numbers, are really easy and nice to test. So let's figure out what is the derivative at 0. Now, I could have picked any number to the left of 5/8. So I could pick 0, I could pick negative 500, I could pick negative 4, just whatever you feel like, but 0 works. Okay, so f prime of 0, well, hey, wait a sec, that's just negative 5. And the important part here is that it's negative. It doesn't really matter that it's negative 5, it just matters that it's negative. Okay, so that means this particular region is a region of decrease. So I put a little negative up on the number line there. Okay, so then we do the same thing for the other number that we want to test. So let's say we picked 1, so f prime of 1. Okay, well, let's see, negative 5 plus 8 times 1, well, 8 times 1 is 8, negative 5 plus 8, ooh, that's positive. Now, technically, it's positive 3, but again, as we go through this, you'll notice that I don't always figure out exactly what the number is. I just kind of do a figure out enough to know whether it's positive or negative. Okay, but anyways, so we put a little positive sign up here on the number line. So the negative is a region of decrease where the function is decreasing. The positive is an area where the function is increasing. And how we write this is we say that f of x is increasing, and we use interval notation for this, increasing on the interval, so we don't have to say on the interval, but increasing on, and then I'm just going to use interval notation. Okay, so that is increasing. Okay, so that's the positive one, so that is from 5/8. Now remember, you can't equal 5/8 because at 5/8 the function is flat, or the derivative is 0, so the tangent line is flat. Okay, so we have circle bracket there for 5/8. We're not allowed to equal 5/8, and all the way up to infinity. Okay, if you really wanted to use the other notation, it would look like this. 5/8, okay, is, or x is bigger than 5/8, which is less than infinity. Usually we don't put the infinity sign, so it would just be that. Interval notation is far easier for this, everyone, so just go with it. Okay, and then the second part is f of x is decreasing on the interval from negative infinity all the way up to 5/8. And again, you can't equal infinity or 5/8, so that's why they're circle brackets. All right, so that's that one. Interesting. Okay, so number 2. Find the interval on which the function that is increasing and decreasing. So same kind of question, just a little bit bigger function. Okay, not a problem. All right, so again, the first step is to take the derivative. All right, so let's see, that's 3x squared. You guys should be really good at this part, at least for these ones. There are some harder derivatives later on, but, we'll get there. Okay, so that part looks okay. Now, once we get something like this, now I taught you guys big X factoring, but it's not important how you factor, it's important that you factor. So whatever method you like to use. Okay, and we want factors that subtract to 4, so it's here and here, that makes 6, that makes 2, we want 4, so plus 4, okay, so it's plus 6 minus, plus minus. Alright, so then f of prime of x equals, Okay, so we have a 3x and a 1x. The 3 multiplies a positive 2. The 1x multiplies a negative 2. Okay, and again, you'll get that regardless of which method you use for factoring. Okay, so there's our derivative, and we want the derivative to equal 0. Okay, so 3x minus 2, x plus 2. Okay, whoop, sorry, my bad. Alright, so that of course just means that x equals 2/3 or negative 2. Perfect. Okay, looking good. Alright, so now we set up our number line again, like I taught you guys last one. Okay, this time we have two critical numbers, two critical values. So tell you what, we've got negative 2. So let's go negative 1, 0, 1, 2. Okay, so let's see, negative 2 would be here, so let's draw a little dotted line through there. Okay, and positive 2/3, that's about here. That's 2/3-ish. Okay, wow, that's exactly great writing, 2/3. Okay, but look, there's 3 distinct regions now. Okay, and I'm just going to erase this part just to give myself a little more room. Okay, so once we have this, again, we're going to pick values in these regions. So we want to figure out the derivative at these certain spots. So I'm going to pick negative 3 because it's the next integer below my first region. Okay, 0 works, so 0's in the middle region, and positive 1 will be in that region to the right side. So I'm going to test these 3. Okay, and when we do that, okay, we find, and we can type this in, whatever, so negative 3. Now look how I do this. I'm just going to look at the factored form of our derivative, so this part here. Okay, right there, yay. Okay, I'm going to undo that so it's not there. Okay, I'm just going to put negative 3 into that. So 3 times negative 3 is negative 9, minus 2 is negative 11. So this part's negative. Okay, and then negative 3 plus 2 is negative 1. So this part is also negative. So a negative times a negative is a positive. Okay, now if you really, really want to figure out that number, well, then I guess you can. So that's negative 11 times negative 1, so that's positive 11. Okay, but again, we don't really need the number, you just need to know that it's positive. So that region there, from negative infinity all the way up to negative 2, is a region of increase. Our function is increasing there. Okay, f prime of 0. So that's kind of nice. You throw that in there. So 0 for x's, so you get negative 2 times positive 2. Hey, that's negative 4. Again, all that's important is that it's negative, so that's a region of decrease. And when you throw in x is 1 into that equation, so 3x, okay, so that's 3 times 1 is 3, minus 2 is 1, so that's positive 1. And 1 plus 2 is also positive, but it's positive 3. So 1 times 3 is positive 3, or just positive. So that region is an area or a region of increase again. Awesome. So now we can say, all right, so f of x is increasing on the interval. Okay, now there's 2 of them. So this first guy, that's from negative infinity all the way up to negative 2. Okay, circle brackets because it's not included. Now we have another one. So if we have 2 or 3 or whatever, we just use this little symbol, kind of like a fat U. Okay, and that means the union of. Okay, so it just means they're this and that. So if you really want to put and, you certainly can, but the math way of doing it is the union symbol. Okay, and then we go from 2/3 all the way up to positive infinity. Okay, awesome. And then f of x is decreasing on that negative interval, and that is from negative 2 all the way up to 2/3. So negative 2 up to 2/3. Okay, so that is how we find intervals of increase and decrease. Okay, a couple more and then we'll be done this part. I know you guys are probably thinking I talk a lot, but yeah, it is what it is. Okay, so find the intervals. Cancel that. Sorry. Okay, find the intervals of increase and decrease on this guy. So again, the first derivative, f prime of x. All right, so that's 12x squared minus 24x minus 36. Wow, see, these numbers get big, but oh, if you look, there's a common factor of 12 in all of them. So x squared minus 2x minus 3. Okay, we want that first derivative to equal 0. So remember, the 12 really doesn't figure in here. We just factor this. Now, I have taught you guys to factor by inspection, but again, whatever method you have, factors of 3 and subtract to 2, 3 and 1, 3 is negative, 1 is positive, so x equals 3 or negative 1. So there's our critical values here. Okay, so if those are the critical values, set up our number line like so, and let's see, so negative 1's there, 0, 1, 2, 3 is there. Okay, so here's our regions, negative 1, positive 3. Okay, marvelous. All right, so numbers to check. Let's try negative 2. So f prime of negative 2, f prime. 0's in that middle region, so we'll check it. And then 3, so the 4 is the next integer, so f prime of 4. Remember, you can pick any number you want in those regions. So you can pick 10 if you think it would make you happy, but the bigger the numbers are, whatever. If you are using your calculator, then it doesn't care how big the numbers are. That is a nice skill to have, typing in your calculator for these, so you'll get good at it, trust me. All right, so f of negative 2. All right, well, when we try that, okay, so we put in negative 2 here, so negative 2 minus 3 is negative 5. Negative 2 plus 1 is negative 1, so you have a negative times a negative, so this is positive. Okay, f of 0. Okay, so that's 0 minus 3, so that's negative 3, positive 1, so you have a negative and a positive. I'm not really dealing with the 12 because it's positive, so it doesn't really change anything ever. Okay, so you got negative 3 times positive 1, so that's going to be a negative. Okay, and then when it's 4, okay, 4 minus 3 is positive 1, 4 plus 1 is positive 5, so a positive times a positive is a positive again. If you really want to figure out the numbers on this step and then figure out positive or negative, that's totally fine. You're just typing the numbers either into that equation, or you can even go right up to the beginning and put it in that equation. You know what, that's probably not a bad idea, because if you put in 0 for that, you would have seen that was negative right away. You didn't have to do any of that other stuff I did. But anyways, regardless, this guy's positive, this guy's negative, this guy's positive. So those are our regions of increase and decrease. So then we just say the function, so f of x, okay, is increasing. Oh, sorry, I got that little line there. Okay, so f of x is increasing on, okay, so negative infinity up to negative 1, unioned with 3 up to infinity. Sorry guys, I'm getting close to the edge there. So 3 up to infinity, and f of x is decreasing on that middle interval, so from negative 1 up to positive 3. So negative 1 up to positive 3, and ta-da, there you have the intervals of increase and decrease for that one. Okay, one more. Okay, find the intervals on which the function that is increasing and decreasing. Confirm your results by graphing on your graphing calculator. Okay, cool. I had to throw one of these in with a little bit trickier of a derivative. So remember, whenever you have an x on the bottom, we're always going to rewrite that as to x plus, in this case, it's going to be x to the minus 1. Okay, awesome. So the derivative of x is just 1. So then that 1's going to come down. So it's going to be minus x to the negative 2. Okay, awesome. So now that we have that, now we're just going to write that better. So that's going to get negative 1 there. So negative 1 over x squared. And remember, the whole point is to make this derivative equal 0. That's how we find those critical numbers. Okay, so that negative is going to come across. So we're going to get 1 over x squared equals 1. Okay, oh look, just switch those guys. So 1 over 1 equals x squared. Well, 1 over 1 is just 1 equals x squared. So, of course, square root, and x equals plus or minus 1. Okay, so that's great. All right, make a little number line here. So we have negative 1, 0, and positive 1. Okay, so draw these little dotted lines on our regions. Okay, perfect. So we have those. Sorry, my negative 1 kind of gets lost in the dotted line there, but whatever. Okay, so numbers to check. Negative 2 would be a good one. That's the next integer there. 0 is always a good one if it's available. And the only reason it wouldn't be available is if there was a critical number on 0, and it does happen. But, okay, oops. Positive 2 we'll check. We can't check 1 because we already know that one's going to be 0. Okay. All right, so negative 2. This one is a little trickier with the whole derivative thing, but look, 1 over negative 2 squared. Well, hey, negative 2 squared, that's positive. Okay, so 1 minus 1 over 4 is 0.75, which is positive. Okay, then we have the 0 thing, f prime 0. Okay, so that guy there is, okay, so 0, 1 over 0 is, ooh, wait a sec, 1 over 0? 1 over 0. You're not allowed to have 1 over 0. Okay, so 1 over 0, this guy here, everyone, this is an asymptote. Interesting. Okay, and we should have looked at that right at the beginning. Sorry, but it's kind of nice to come across one of those things and say, hey, yeah, we've got to look at the original function. So look, x here cannot be 0, because if it is, then we get an undefined function. What that does for us is it kind of increases our regions. Okay, so this guy is undefined. So we're going to have to split him. Okay, so let's try 0.5. So f prime of 0.5 and f prime of, oops, sorry, that'd be negative 0.5 back there. So negative 0.5 and then positive 0.5. So we try those ones then. Okay, and remember, that only happens when we divide by 0 or take square roots of negatives, right? That's kind of a big deal as well. Okay, so anyways, we look through that. The negative guy, he is negative. Okay, and f prime of positive 0.5. Okay, this guy works out to a positive. Again, you can type those numbers in if you really want. But yeah, you're good. All right. So once you have those, now, oh, sorry, and f prime of positive 2, okay, that was positive again, sorry. Sorry, guys, I just want to check my numbers here on these 0.5s, because I just want to double check. Always a good thing. All right, so let's see. 1 minus 0 over 0.5 squared. 0.5 squared is 0.25. Okay, and then 1 minus 0.25. Sorry, guys. 1 minus 1 over 0.25. Oh, so yeah, that's negative 3. And we have the same thing here with the 0.5, so that's also going to be negative. See, I did get that one wrong. Sorry, my bad. That's why we check these things. So that guy is negative as well. All right, so this region we said was positive, this region we said was negative, this one is also negative, this one is positive. Okay, so we have in our function, so f of x is increasing on the interval, okay, so negative infinity up to negative 1, and from positive 1 up to positive infinity, and f of x is decreasing on the interval from negative 1 to 0, okay, union with from 0 up to positive 1. Now remember, it's important, because I know what you're thinking. You're thinking, well, why can't I just leave those all in one thing? Well, remember, we're never allowed to equal 0. And if you were to say from negative 1 to positive 1, hey, 0's included in that, isn't it? Okay, which means you can't do it. So anyways, x can't be 0. That's from the original part here. Okay, and we go from there. Now, if we make a quick sketch of this thing, well, we're not supposed to make a quick sketch. We're supposed to look at this on our calculator. So I will show you kind of what that looks like. Negative 1 and positive 1. The graph kind of does something weird like this. Okay, and then down, so you have a maximum point there, and a minimum point, and it kind of does the same thing like that. Okay, 0, of course, is an asymptote because you're never allowed to divide by 0, and we go from there. So, I know this was a little bit longer. This is the start of a new unit. You guys will be all right, and just remember the fundamentals. We might have to watch this video a couple more times. Not a big deal. Call me if you need anything. Thanks.